እሺ ሰላም ባለፈው ቪዲዮ ከሊኒየር ሪግሬሽን ጀምሮ እስከ ኤልኤልኤም ድረስ ራን ኦር ድራይቭ ስሩ አድርገናል። ጀስት ጀነራል ኦቨርቪው ኦፍ ኢች ኤንድ the progress in machine learning and everything። ዛሬ እንግዲህ ከመጀመሪያው ጀምረን ከክላሲፊኬሽን ከዛ ሪግሬሽን እያለን ኒውራል ኔትወርክ ኢን ዲቴል በእያንዳንዱ ላይ ፕራክቲካል ፓይተን ኤግዛምፕል እየወሰድን ኢምፕሊሜንቴሽን እያደረግን እንሄዳለን ማለት ነው። ሶ የዛሬው ቪዲዮ ኢዝ አባውት ክላሲፊኬሽን ኤንድ ሪግሬሽን ትሪ ወይም ካርት የሚባለውን አልጎሪዝም የተወሰነ እናየዋለን። በአጠቃላይ ስለ ዲሲዥን ትሪ አይዲያ ቢሃይንድ ኤንድ ሃው ኢት ወርክስ የሚለውን በዛሬው ቪዲዮ እንማማራለን ማለት ነው። Okay, so we will cover this a lot of stuff today. ሀያ ምናምን ስላይድ ነው ያለን ብዙም ሰዓት አንፈጅም። So to start with, what are decision trees? And we talk about the famous Titanic example. Titanic example ማያውቅ አይኖርም in decision tree or machine learning ሲባል ያው Titanic dataset have been used in በብዙ ቦታ ላይ ስለዚህ ስለሱን ትንሽ እናያለን እንደ ምሳሌም እንጠቀመዋለን እንደ practical implementation case ጊዜ. And then we'll talk about the mathematical foundation of this decision tree, and we talk about split rule, classification versus regression, how does decision tree works for both cases. ከዛ impurity measure አለ, and then we'll talk about the CART algorithm. We have a pseudocode about it. ከዛ overfitting and solution and practical tips and tricks, and then hands-on example. በሚቀጥለው ቪዲዮ የፓይተን ስክሪፕት አብረን ራን እናደርጋለን ማለት ነው። and then we'll summarize it. Yeah, and what if I told you you could make complex decisions using simple yes and no questions? And that's exactly what decision trees do. So ችግራችንን ያለንን research question, it asks yes and no question, and then if yes you go left, if no you go right. So as simple በቀላል እንትን በዚህ መልኩ ነው ዲሳይድ ክላሲፋይ የሚያደርገው or categorize የሚያደርገው። ለምሳሌ in real life example ስንወስደው should I go outside? so የሚለውን ውሳኔ ለመወሰን መጀመሪያ we look for variables. ቅዝቃዜ እንደ variable, መዝነብ እንደ variable ብንወስድ the first question is it raining? so you have yes and no. If it's raining you stay inside. If it's not raining then you look for another variable. የሚመጣው variable ምንድነው? ቅዝቃዜ ነው። is it cold? ቀዝቃዛ ከሆነ still you stay inside. if not you go outside. So to reach to the decision to go outside, you pass through multiple stages of decisions or split rules. Split rule alpha ነው እዚህ ምንደርሰው. Another key insight, decision trees split data using simple rules to make predictions. ስለዚህ እነዚህ ይሄ so it's a በጣም ሲምፕል ነው። በጣም we'll talk about the characteristics of decision tree, but this is the basic idea behind ከዛ በኋላ random forest ምናምን እንላለን፣ ግን this is the backbone idea. the goal in ለምሳሌ በታይታኒክ ዳታ ላይ survival prediction አንድ ሰው ታይታኒክ በሰመጠ ጊዜ በህይወት የመትረፍ ፕሮባቢሊቲውን ስናጠና the goal is to predict survival from passenger data. So we have passenger data which constitute future features of sex, age, passenger class, number of siblings, ticket fare. So sex can be male and female. This is Boolean. This is categorical variable. And not Boolean. Boolean is for true and false, right? age in years ይሄ numerical variable ነው passenger this is categorical and number of siblings is number and ticket fare ስለዚህ our prediction መጀመሪያ መሰረት የሚያደርገው we take variables right እዚህ ጋር ከላይ የምታያቸው sex variable ነው age variable ነው number of sibling variable ነው so we do or the cart or the decision tree algorithm የሚያደርገው ምንድነው it takes variable and then it checks with the split rule is it male or female በዚህ case if he is male and if he is not female or of course he is not female if he is male በዚህ decision ጊዜ ለምሳሌ sex is male then you go to the age sex female ከሆነ ግን by default survive ታረጋለች 73% so if sex is male then you just check the age ከዛ እድሜው ደግሞ የሰውየው ከ9 ዓመት ነጥብ 5 በላይ ዓመት ነው ወይስ አይደለም ከ9 ዓመት በላይ ከሆነ እንደገና ወደ ታች እንሄዳለን ከ9 ዓመት በታች ከሆነ ግን by default survival rate 89% ነው ከ9 ዓመት በላይ ከሆነ ደግሞ number of sibling ያለው የሲብሊንግ ነምበር ከ2.5 በላይ ነው ወይስ በታች ነው ከ2.5 በላይ ከሆነ የመሞት ቻንሱ 70% ነው ከዛ በታች ከሆነ ደግሞ 5% ነው ሶ እዚህ ጋር የምታዩት ዳታ ላይ እንግዲህ ፊሜል መሆን እድሜው ከ9 ዓመት በታች መሆን እና of course sibling number of sibling small number of sibling መኖሩ kind of influence the decision it can tell you that ህፃናትንና ሴቶችን ምናምን ለማዳን ቅድሚያ ሰጥተው ነበር ማለት ነው it gives you an insight so basically this is how decision tree works so አሁን ባየነው ዳታ መሰረት based on the Titanic tree what would happen to a 25-year-old male passenger with one sibling right መልሰን እዚህ ጋር ማየት እንችላለን 25-year-old ማለት already he is male right so you come to this and he is more than 9.5 you come to this and he have one sibling right ስለዚህ ወደዚህ ሳይሆን በዚህኛው ሳይድ ነው የሚሄደው and the answer would be 5% survival or 95% he would probably die if he's a person male greater than 9.5 age and more sibling ያለው ከሆነ the chance survive ማድረግ እንትሉ 5% ነው ማለት ነው based on decision tree this is a very simple example and coming to the maths behind it's also very simple and straightforward in the decision tree case and a tree is defined by this parameter theta and 5 measurements or parameters and theta this is the tree L is the number of leaves T binary tree structure or the generally the tree structure and so leaves ማለት ልክ እንደ አናሎጂውን በዛፍ ማየት ትችላላችሁ so leaf is the last age right so these are the leaves on the last group some certain ግሩፖች መጨረሻ ላይ የሚገኙበት ማለት ነው leaves so that's the number of leaves and variable selection for each split rule or threshold prediction values for leaves so this will affect how the decision process goes so mathematically the goal is to find the predicted tree with the arg mean of the expectation of theta or the tree where the expectation of theta is given by a function d of the theta or the tree by the observed data or this is just the fitting of the data, and plus some normal regularization term. So lambda here እዚህ ጋር the strings of the penalty or the regularization that we want to do የሚለውን strings-ን እንትን ሲል ይሄ regularization ደግሞ it will be also defined after ምን አይነት regularization እንደምንጠቀም we will decide based on the advantage and based on different factors. So basically this is a general formula and data fitting term or accuracy. እና the other term is the regularization term or complexity penalty. So basically we penalize um, the fitting so that we avoid overfitting and yeah, complex ምን ማለት እንደሆነ እናያለን. How do we split the data? Okay, maybe regularization የለም መሰለኝ. So there are two types of regularization እዚህ ጋር L1 and L2 regularization. Where በL1 regularization ጊዜ or also sometimes called lasso regression ይባላል. Lasso regression. So penalize የምታደርጉት the absolute value of the term, the absolute value of the thetas sum በማድረግ ነው ተደምሮ absolute value የሚደመረው and በL2 ጊዜ it's a ridge regularization ይባላል እና the mean squared the squared error yeah, the sum of squared error will be added to the fitting so that it will penalize high weights of predictions and በጣም overestimate እንዳያደርግ የተወሰነ ይጫነዋል ማለት ነው። Yeah, I don't think I have a slide for regularization here. But let's go on. How do we split the data for numerical variables? Number ሲሆን is it less than or greater than? ለምሳሌ እድሜ ከሆነ variable the split rule can be if age is greater than 50 or no. ቀደም እንዳየነው እዚህ ጋር ያው age is 30 if categorical ከሆነ is A is a subset of B or is A in category A or category B as in sex ማለት ነው. So here a tip would be for K categories. If we have K categories, then the possible splits can be calculated by 2 to the power of K minus 1 minus 1 possible splitoች ይኖሩናል ማለት ነው። ለምሳሌ if we have 4 categories and then we have 2 to the power of 3 8 minus 1 7 possible splits ይኖረናል ማለት ነው። Coming to the classification tree, the goal ማለት እዚህ ላይ predict the categories ቅድም እንዳየነው I think regression tree አላየንም. Yeah, okay, so classification tree ላይ the goal is to predict the categories, right? If A is survived and not survived or died, spam or not spam, and the evaluation function if we are doing ትክክል እንደሰራን ወይም ፕሪዲክሽኑ ትክክል ይሁን አይሁን የሚለውን ኢቫሉዌት የምናደርገው using this evaluation function or this loss function ነው። The loss function in classification trees is calculated by the sum of ይሄ h naught h theta of xi የሚለው I ማለት እያንዳንዱ ኢንትሪ ነው። x is the input data and is not equal to yi. So basically this is conditioned or the condition ይባላል። ኮንዲሽኑ ምንድን ነው? misclassification error ነው። ለምሳሌ h not classify this is a tuple, right? We have an input x and as is not equal as or not classified in label I. I class ላይ ሆኖ is not labeled as I in the Y. So that's not this is the misclassification of the misclassification error ለምሳሌ ወንድ ሆኖ ወንድ ላይ classify ካልተደረገ this will be captured here. And the regularization again, this term will be the leaf prediction and most common class or mode. So in this case classification tree ሲሆን ብዙ ጊዜ predict የምናደርገው we are not ብዙ ጊዜ but we predict የምናደርገው class ነው or category. So basically if a leaf has 20 survived and 5 died የመጨረሻው እቺ አንዷ የቀረችው ክላስ ሊፍ አብዛኛውን ክላስ የክላሱ አካል 20 ከሆነ then it will predict survived given አምስት only died ካለበት ማለት ነው። so 20 survived and 5 died. so proportionally ስናየው 20 is like 4 times more than the died proportion. so prediction work የሚያደርገው is based on the proportion of misclassification. No, this is how the evaluation function works for classification tree. In regression tree we predict continuous values, numbers, ለምሳሌ age, price, temperature, and the evaluation function is given by so standard error or like a squared mean squared error ይባላል. and this is also regularization term. and the idea ማለት the idea ምንድን ነው? we have the this h naught xi, this is the prediction we have, and minus the true value of y, and that's squared. so that basically what we have as a mean squared error, and the leaf prediction is the average value. ቅድም ያየነው ክላሲፊኬሽን ላይ ሊፍ ፕሪዲክት የሚያደርገው ቤዝድ ኦን ፕሮፖርሽን ነው። ያ ማለት ቤዝድ ኦን ሞድ ቫሊዩ ነው። እዚህ ጋር ደግሞ ቤዝድ ኦን ሚን ነው፣ አቨሬጅ ነው። ኢትስ ያ so this is the prediction minus the true value and square, and you sum over the entire input and then you get the value ማለት ነው። ለምሳሌ if a leaf has a house price 200k 250k 180k አንድ ሊፍ ውስጥ ቢኖር leaf predict 200k predict 200k because 200k is the mean value for this one. yeah, so basic difference እዚህ ጋር ማየት ያለብን ዋናው ወሳኝ ዲፈረንስ ምንድን ነው? yeah, so this is a misclassification error, and it's mainly dependent on the proportion of classification ምን ያክል ጥሩ አግኝተናል. and here is the standard error or the mean square error of the three given the data. so ወደ መለስተኛ reminder or ጥያቄ ነገር which is more pure ለምሳሌ leaf A 90 survived ቢኖረው 10 died, and the leaf B ደግሞ 50 survived 50 died ቢሆን የትኛው ነው pure? so we'll talk about purity in a bit. just think about this. so you can think more pause አድርጋችሁ ግን for the sake of time obviously leaf A is more pure. ምክንያቱም እዚህ ጋር ፒዩሪቲ ማለት የአንድ ግሩፕ በአንድ ቦታ ላይ just impurity እንደ ወርቅ ብታስቡት ወርቅ ኮምፓውንድ ምናምን አሎይ ምናምን ሲገባበት ፒዩሪቲው እየቀነሰ ይሄዳል። ሶሊ ጎልድ ብቻ ሲሆን ፒዩሪቲው በዛ ሌሎቹ ኤክስትራክት እየተደረጉ እየወጡ ሲመጡ then it gets more pure. so we have 90% survived እዚህ ጋር we have 10 died. so leaf A is more pure. It is easier to make accurate prediction when one class dominates. so basically in decision tree we aim to have as pure leaf as possible at each node or at each leaf. Yeah. So let's talk about impurity measure. ለምሳሌ ቅድም የጠቀስኩት ያነሳሁት ሀሳብ እዚህ ጋር impurity ነው። So back to the slide here. እያንዳንዱ እንትን ላይ ሰዎች አሉ፣ group of people አለ, right? So ምን ያክል pure ነው እያንዳንዱ group ላይ? Maybe the example is not very smart, but impurity has to be checked. impurity ማለት አንድ ሊፍ ኖድ ተከፋፍሎ፣ እሺ ለምሳሌ ሀብታም ለመሆን ምንድን ነው የሚያስፈልገው? ወንድ መሆን፣ ሴት መሆን። ኦኬ ሴት መሆን ነው። ወንድ መሆን ከሆነ እሺ ወንድ መሆን እድሜ ከ20 መጨረሻ ሊፉ ላይ ስንደርስ we want as pure as ተመሳሳይ የሆኑ ግሩፖች እድሜያቸው እንደዚህ የሆነ ምናምን እንዲህ የሆነ ምግብ ይበሉ whatever ብቻ እዛ ግሩፕ ላይ ተመሳሳይ ፊቸር ያላቸው ተመሳሳይ እንትን ያላቸው ፒውር የሆነ ግሩፕ ነው የምንፈልገው። ሶ ሜጀር የምናደርገው ይሄንን ኢምፒዩሪቲ ወይንም how much we succeed in actually training or in actually creating a classifier is by measuring the impurity. So እዚህ ላይ የቀረቡት ወደ 3 impurity measures አሉ። The first one is misclassification error. So misclassification error is actually the easy one, and this counts how many examples would be misclassified if we predict the majority class, right? ለምሳሌ አንድ ያ 100 ወንድ ያለበትና 20 ወንድ ያለበት 20 ሴት ያለበት ግሩፕ ላይ just 120 ቢሆን we would like to know the misclassification error, basically the proportion ማለት ነው. So it's calculated by 1 minus the maximum proportion of a class K. So maximum ማለት የወንዶቹ already maximum, so you calculate 100 over 120 and then you get the proportion of K and you ከአንድ እንቀንሰዋለን. So we have the misclassification error. misclassify የማድረግ ፕሮፖርሽናችን ይሄን ያክል ነው እንላለን ማለት ነው። when you come to Gini and entropy, so basically አሁን ጁፒተር ኖትቡክ ላይ ራን ስታደርጉ by default Gini index ነው የሚጠቀመው unless you explicitly mention the entropy or cross entropy stuff, it use Gini. So Gini index is basically the measure of the probability of misclassifying, but if you take one random set of ዝም ብለህ አንድ ሰው ከግሩፕ ውስጥ አንዱን ሰው ብናነሳው the probability of that person being misclassified, right? So it measures the probability of misclassifying a randomly chosen example, right? ስለዚህ the idea ምንድን ነው? You sum over the probability or the proportion of pk times 1 minus pk. So pk being the proportion being in class K. And then yeah, so times ለምሳሌ the Gini probability of ሁለት ወንድ 5 ሴት ቢሆን 2 over 7 ሲባዛ 5 over 7 ማለት ነው, right? So it's just the idea is proportion of K being in a class K times 1 minus pk and sum over that. Entropy is the most widely used optimizer or entropy measure, and ለየት የሚያደርገው it's a little bit minus አለው ከፊት ለፊቱ and pk times log of pk. So በዚህ ኬዝ So logarithm of the proportion is always negative. So እዚህ ጋር negative የሆነው is because the logarithm of a proportion or the logarithm of decimal points is always negative. So to cancel out the negative, and then the pk times the logarithm of pk. So that's called entropy. The idea is we always want lower impurity, right? We want the leaves as explicit as possible or as pure as possible. Yeah. ለምሳሌ example, node with 400 class A, 400 class B, and like 0.5 proportion. Let's say split 1 does 300A, 100B, and 100A, 300B, and split 2 does 200A, 400B, 200A, and 0B. Which split is better? Is it split 1 or split 2? Split 2 is obviously better, right? ምክንያቱም we have 0B. ማለት ፒውር የሆነ አንድ ሊፍ አለን ማለት ነው. So we are our prediction, it makes the prediction easier. And what Gini and Entropy measure will prefer split 2 over split 1. Yeah, so splitting happens in every node. It's important to keep in mind every node lay, and then it chooses variable, the best variable to do that as well. The cart algorithm, the default algorithm in sklearn or in PyTorch the default algorithm is the cart algorithm, and in simple word this is the pseudo code, and start with one leaf containing all the data, everybody else in one node, and for each possible split calculate the impurity reduction. Impurity reduction የትኛው የተሻለ impurity reduce ያደርጋል የሚለውን calculate ያደርጋል, and keep track of the best split. So in a sense it is greedy, or it will only look for the short term good variable to split. ለምሳሌ አሁን ላይ ስፕሊት ሲያደርግ በጾታ ስፕሊት ማድረጉ የተሻለ measure of impurity, less impurity ያመጣል ብሎ ካሰበ it will use that. ግን in general in future prospect of classifying further የሚያመጣውን consequence አያይም. So it's a way of it's a greedy way. greedy ማለት እንደዛ ነው. So make the best split if improvement is significant. So keep doing the split and split until the end. So the end ማለት የመጨረሻ ግሩፕ ላይ ማንም ሌላ ሰው የለም፣ አንድ ብቻ just this specific የሆነ pure group እስከሚፈጠር ድረስ classify ታደርጋለህ or split ታደርጋለህ until some stopping criteria. We'll talk about what are the stopping criteria, or why is it a very bad idea to let the tree grow very big. Prune the tree. Pruning ቀጥሎ ስላይድ ላይ አለ. So basically overfitting happen ያደርጋል. The general idea, አንድ ዳታ ወሰድን እየከፋፈልን ስፕሊት እያደረግን ስንመጣ at the end we'll reach to the point እዛ ስፔሲፊክ የሆነ ሊፍ ላይ አንድ ሰው ሊሆን ይችላል የምናገኘው። ለምሳሌ ዩኒቨርሲቲ ላይ የሚያስተምር or ዩኒቨርሲቲ ተማሪ ብለን ካልን የዩኒቨርሲቲ ተማሪ ወንድና ሴት እንከፍላለን። ከሁለተኛ ዓመት በታች ከሁለተኛ ዓመት በላይ እንከፍላለን። ከዛ ኢቨን ሞር እየከፈል ነው በሄድ ቁጥር እድሜ ከዛ ከዚህ የመጣ ከዚህ so specifically tree won't stop growing, so it will end up identifying a specific person, or it will just create a leaf for one person. We don't want that. That's called overfitting. So to avoid that, we will talk about pruning. So the problem is finding the optimal tree is computationally hard. So የቱ ጋር ነው ማቆም ያለብን? So cart use greedy heuristic. So greedy heuristic ማለት ቅድም እንዳልኩት it will only check the current status. It thinks that it's less pure. Um, minimize the impurity. Yeah, for a quick Python implementation, I don't think we will do this, but በሚቀጥለው ቪዲዮ ላይ Python implementation ነው የምናደርገው። ግን this is a simple text. Yeah, we import libraries and we load the data, the Titanic and age. So we will see age, sex, and passenger class, and we will predict the survival and yeah. So we'll see this in the next video, actual implementation. So the overfitting problem is this is underfitting, just to like make a smooth transition. So ለምሳሌ እንደዚህ አይነት ዳታ ቢኖር if we have our line fits like this, ምንም ሪፕሬዘንት አላደረገም እዚህ ጋር ያለውን ዳታ። በዚህ ጋር ስንመለከተው ግን it sort of had a nice way of classifying these two classes. Like this is very linear classifier, and we have some appropriate classifier somehow. እዚህ እና እዚህ ጋር ብለን እንከፍላለን። አረንጓዴው የሚገኝበት እዚህ ነው፣ ይሄኛው ሰርክሉ የሚገኘው እዚህ ጋር። so this is appropriate fitting ነው። ግን if the model or the fitting go like this, extremely or force fitting, it's too good to be true ማለት unbelievably እያንዳንዷ ዳታ ፖይንት ላይ የሚያደርግ ከሆነ this is overfitting, that is it memorizes everything ማለት ነው። so without regularization tree can memorize training data perfectly. ያ ማለት ትሪው በጣም አድጎ በጣም ዲፕ ሆኖ it can goes to 1%. So it's basically memorizing. So sign of overfitting የምንላቸው it's perfect training accuracy. Nearly if your training accuracy is 1, that's very bad sign, or that's a good sign in another way that you are overfitting, and especially if it performs bad in the test accuracy. So very deep trees with many specific rules. ቅድም እንዳልኩት በጣም ሩሎቹ እየተከፋፈሉ መጥተው ስፔሲፊክ የሆነ አንድ ግለሰብ ላይ ኦር አንድ ፊቸር ኦር አንድ ሳምፕል ላይ ይመጣል ማለት ነው። so that's not a good thing. each leaf contains very few samples. ያ so ሳምፕሉ በአንድ ግሩፕ ውስጥ ያለው በአንድ ሊፍ ላይ ያለው የሳምፕል ብዛት በጣም ሲያንስም basically similar ስለሚሆኑ that's very overfitting. yeah of course similar ማድረግ ነው ግን yeah not as if it will think everyone is the same. so solution pruning ማለት ልክ ዛፍ እንደሚከረከመው ሁሉ ትሪውን ይሄ ዲሲዥን ትሪውን መከርከም ማለት ነው። pruning or early stopping, and we decide on maximum depths, the limit of the tree depths, how much deeper we can go, and minimum sample split, minimum samples to split, and minimum samples per leaf. This is a hyperparameters that we can decide in the training. Yeah, post pruning, grow large tree first and remove branches that don't improve validation performance. And the other good way is also cross validation. Cross validation ማለት test multiple hyperparameter combinations, choose settings that generalize the best. so cross validation and yeah, post pruning help in adjusting or help in improving with regard to the overfitting of decision trees. For better trees, yeah, create meaningful categorical bins for continuous variables. ለምሳሌ age group ምናምን transformation ላይ careful የሆነ transformation ማድረግ, handling missing data, Yeah, and feature selection also is a good idea to have before actually doing the training. and use ensemble methods እናያለን ወደፊት ስንመጣ እንደርሳለን የኤክስጂ ቡስት እንዴት እንደሚሰራ and random forest also is on the list. And so random forest basically means many trees voting ማለት ነው. and XGBoost is you can think of it as a random forest but in a different way of voting or sequential tree improvement ሜትር ነው የሚጠቀመው. we'll talk about it. and ideally decision tree መቼ ነው የምንጠቀመው? it's interpretable ነው እንዳያችሁት input and the output are very clear, and how we get to the decision to go out and stay home is clear, and we can reason that we can use it numericalም ለካቴጎሪካልም ዳታ ልንጠቀመው እንችላለን. and yeah, non-linear relationship ካለ it will take care of that. and feature selection and ranking ላይ ብዙ ጊዜ ይጠቀሙታል. but ማትጠቀመው ግን ወይም መቼ ነው ሌላ አማራጮችን የምንመለከተው? if we have high dimensional data and if we have linear relationship, we could use linear regression when you need probability calibration. and if you have a new noisy data, you should not probably use decision trees. yeah Python implementation no. Final challenge: you have a dataset of 1000 email, and if 800 legitimate emails and 200 spam emails, your tree create a leaf with 50 legitimate email and 150 spam emails. So what would this leaf predict for new email? አዲስ ለሚመጣ ኢሜል ምንድነው predict የሚያደርገው? yeah you guessed it right. So it will predict spam basically. so since in the leaf 150 majority class ያሸንፋል ማለት ነው always in the decision tree. yeah we talked about decision tree, making prediction using simple and yes no, and we talked about cart algorithm and that it's greedy. In a sense, it will find the best split at its current position or current split. Impurity measure help evaluate split quality, and regularization prevent overfitting. Okay, I think we'll do a video about regularization and how that work. Three are interpretable and handle mixed data type well. They form the basis for powerful ensemble methods. And next topic we'll talk about random forest, XGBoost, and all that. And yep, thank you. And if you have questions, drop them in the comments, and yep, subscribe. And in the next video we'll do an actual decision tree በጉግል ኮላብ ላይ ኮዱንም ሼር አደርጋለሁ. and then we'll talk about the code and what happened in every line of code with the simulated data in Ethiopian context. Yep, appreciate it. Bye bye.